Anyone hear me? Hmm. Okay.
Hello, everyone. Welcome to the session of user engagement. I'm Subramanian. I think our first speaker, Yasin, is ready with the presentation. So can I request the speaker to get started with the presentation?
Yes, thank you. Yeah, so hello everybody. My name is Yasin, and I would like to present our work, which is about a survey of volumetric content streaming approaches. First of all, I would like to give a short introduction about myself. I am a PhD student at Technical University of Darmstadt, Germany, and my research interest is about machine learning and communication system.
Yasin,
So
may I request to start with the presentation?
yeah, do you hear me? Hello?
I think he already started. I think he can't hear your audio.
Yes, so
Maybe write him a chat message.
okay. But Jonas said he can hear me. So anybody has a problem hearing me?
Yeah, sorry, there was an glitch on my side. Sorry, please continue.
Oh, okay, okay. So I will continue. So I will start my talk with a small motivation about volumetric content. So actually nowadays we have a really big advancement in the hardware for generating high quality content. So and also we have this hardware to viewing the content, and so we can easily produce 3D high quality content, and for sure we need very high requirement for that in terms of processing and communicating this content. On the other hand, actually, we see that the user seeks for more interactive and immersive experience. Like, for example, Pokemon Go, if you may know it. So it's a very simple idea that we introduce or host some augmented object into in our reality, and which has created a very good experience. And we see that within the time that the user actually seeks for this immersive and interactive experience. And if we see these two dimensions, that we can produce high quality content on one hand, and also this content can provide us with high interactivity and immersive experience. So we are toward volumetric content, which has these capabilities. And actually, volumetric content streaming has multiple or many applications, like in entertainment, in social networking, and for sure in autonomous driving. So nowadays, autonomous car has some kind of LiDAR, which captures the surrounding environment, and this actually data can be represented as volumetric data or volumetric media. And so after this small motivation, I will give some background information, and then I will talk about desired feature of any streaming system, and then I will highlight some state-of-the-art streaming systems, and then talk about some open research questions. Okay, actually, point cloud is one representation of volumetric content, and it's a very hot topic nowadays, and for researchers. And actually, point cloud is very simple format content. It's just a collection of 3D points, and each point associated with some attribute, color, for example. As we can see here, this human being object can be represented as a set of points, and for each point, actually, there's some attribute, in this case, RGB. And actually, the format itself is very simple, but we require thousands of this point to represent high quality object. And for this, actually, we see that within more points require more bandwidth. This is actually for one frame. And actually, to render this in the phone device, we need, for example, this is in milliseconds. And also on the server, we need to decode this, we need for 14 milliseconds. On the server, actually, here not a milliseconds, is a frame per second. So we can decode 14 frame per second for this amount of points. And actually, for more points, we actually can only encode 1.5 frame per second. And on the server, so we can actually do more or perform more, but still, actually, we see that actually we need a lot of intensive, or we have a lot of intensive overhead on the machines. And actually, for any streaming systems, we have some content on the server side, and this content can be compressed by nowadays or most recent MBIC standards for compressed geometric or volumetric content, either by video-based or geometry-based. And this content can be transported by Dash, like any 2D regular video. And here we have two options if the user has the powerful equipment to compress and rendering the code or the content. So actually, we can deliver the content and do all the rendering and decompressing operation as a client side. Otherwise, if actually we have a mobile device users, so we need actually like edge computing to do all the heavy lifting operations as the edge server, and we stream like regular video to the user. But actually, we need also to receive the feedback so we can actually update the view accordingly. And actually, main challenges for this streaming system, for sure, distribution through the web or the internet is very challenging. The mobile device also is because we know actually computational burden on mobile clients, and also high amount of user interactivity. So feedback should be, we need to interact with the user or response to the user instantly, and also how we can measure the quality of this experience. Also, this is challenging to us, and also to do analytics within this high or low latency application. So actually, to compare between different approaches, we select this 4 criteria, which is network adaptive and user adaptive, and portability and deployability. By network adaptive, we need actually the streaming system should support fluctuations, for example, in the network. And for user adaptivity, the streaming system should actually react to the user movement or hardware capabilities. And also for portability, we need to deliver this content to, for example, affordable head-mounted devices or even our commodity mobile devices. And deployability also, this is for protocols like we need the streaming system to use as much as a standard protocol as possible, so we can deploy this streaming system on our current internet. So actually, for network adaptivity, the streaming system should handle limited throughput, for example, and also should manage to handle different quality representation. So as you can see here, we have two different representation, one with 4.5, require 4.5 megabit per second, and the other higher quality, we need 40 megabyte per second. So the streaming system should support this two kind of representation or different kind of representation, so the system can adapt to network fluctuations. Also, the system should remove unimportant data, so by that we can maintain some bandwidth, and also we can apply some mechanisms or methods like in 2D video by frame skipping, for example. You can skip from some data which is not just to keep the experience as high as possible. And also the system should handle jitter and delay in network by buffering, and also we need to switch between heterogeneous network like 5G and Wi-Fi. And also the second feature is user adaptive. By user adaptive, the system should react to the user instantly, and by that we need to do some predictions. So we need, for example, to predict the upcoming 2 seconds, for example, for a viewport, so we can fetch the content in advance and provide it to the user in case the user move his head suddenly. And also for high degree of freedom, like in 6DoF, for example, the user not only can move his head, but also his body inside the scene or navigate into the scene. So also we need to predict the trajectory, and this is a very complex task. Also, we need to be actually adapt to better status, hardware capabilities. And here's an example. For example, we have a user standing here and looking for these 3 objects. So in this actually object, because it is very close to the user, so we need to stream this object in high quality. But this is actually far object, so it could be streamed in low and medium quality, and this is very far object should be streamed in low quality. By that, actually, we can save bandwidth and also maintain high quality of experience to the user. And actually, for portability, we need to use affordable head-mounted device and mobile device, so we can actually interact with volumetric content using Android, for example. And also deployability, we need the system should use Dash or point cloud library. So actually, this will ease the deployment process. And the first volumetric media streaming scheme I would like to talk about is Nipola. Nipola is very interesting because the author of this work actually tried to provide volumetric content in commodity mobile device. And actually they were able to do that by actually taking advantage of edge computing. So they actually use this edge proxy between the server and the client. The edge proxy is near or close to the users. So all the heavy lifting operation will be done on that server. So, and then they stream some or 2D regular video to the user, and then getting feedback from the user and predicting the viewport and fetching actually the content from the server accordingly. And actually this approach shows some good saving bandwidths and network adaptations, and also was the best actually portability because it can work on mobile device. Another actually streaming system, which is the author of this work actually tried to extend Dash. Dash mainly used actually for 2D video, like regular video, like YouTube, but actually they try to extend Dash to support also point cloud. In this work, actually, they have a raw point cloud and can be sublink to many different representations, from low to medium and high. And then actually, according to the current bandwidths between the client and the server, the buffer manager will actually fetch the suitable representation or quality. So here in an example, this is a manifest file of Dash. So we can see for this point cloud object, we have three different quality. And actually, if we have high bandwidth available, so for sure the buffer manager will fetch the highest quality available. And also for this system actually shows bandwidth, but saving bandwidth performance very high, and also network variation due to actually extension of Dash. And as a third actually approach, in this approach, they actually use here they proposed 3D tiles. So actually here we have a 3D object which can be divided into three, in this case, three partitions or 3 parts. And for each part, actually, we can provide different representation. So the introducing of this 3D tile idea give us actually to stream the same object in different quality. So if, for example, if the user look at the head of the object, so we can stream the head only in high quality, but actually the lower part of the body could be streamed in low quality. So actually introducing a 3D tile give us this flexibility. So this system actually was more flexible to bandwidth fluctuation or network adaptations because actually the flexibility of this 3D tiles streaming. In addition, actually, to just 3D tiles, they propose viewport information also, and also the hardware capability on the client side. All of this information can be actually integrated in one utility function, and according all of this operation, all of this information, the utility function will actually tell what content we should fetch from the server at the current time. This actually, this system actually was a very network variation due to flexibility of the 3D tiles, but actually it's not deployable because they use actually their own protocols, not actually depending on Dash. On the actually the last streaming scheme here, they used actually multi-tier quality, let's say. So we have base tier and rate and enhancement tier. So we have 2 buffer. The first buffer, which has actually the spherical frame, which is about all the view or spherical view of 360 video, and then actually, according to the information from where the user is looking at the current moment, we fetch this part of this spherical frame in high quality. So we have two different buffer, and by that actually we can maintain high quality of experience. And also they use 2 heterogeneous network. So actually they use Wi-Fi to fetch the overload or the heavy lift part of the content, and they use 5G for correction and retransmission. And actually this work was mainly for 360 video, not volumetric video, but also actually we find that the finding in this work is also applicable for volumetric content. And also here the system shows very network variation adaptations, and but actually computing cost was lower. So here actually is a different 4 different approach, and we compare against, and actually we saw there is no one approach solve everything, but there's trade-off between complexity and deployability. And as a conclusion, actually volumetric content has a great actually possibility or potential to establish immersive experience, and also a high degree of freedom actually, or viewing this create a degree of uncertainty. For example, in case of 6 degree of freedom, we need actually to predict the movement of the or trajectory of the user, and this is actually very complex. And also overloading or using edge computing, so server near to the users, we can actually overcome or reduce the bandwidth requirement and power computational burden on the client device. And actually, for a future directions or open research question, that how we can actually, as we saw that prediction is is a big part of streaming streaming systems. So actually, machine learning can play here a role to predict this viewport or trajectory. So this is also an open research area. And also we need to minimize the end-to-end latency as much as possible. Actually, so we can have live volumetric content streaming. And also for computational requirement, can we employ some hardware point cloud encoding, decoding? So far, actually only point cloud decoding or encoding is done by software, but not by hardware. And also open research topic for caching such a content, how we can cache volumetric content, so we can reuse this cache to provide or to use this data to another users. So that was my talk. I hope you enjoy it, and please feel free to place your question.
Thanks, Yasin. So any questions? All right, so perhaps I don't see any questions. So in that case, can I request a volunteer to allow for the next speaker to present?
Yeah, hello.
Yeah, please continue.
Yeah, actually, I'll be presenting now, and I don't have the share option. Like it is disabled for me.
Oh, I see. So, okay. I'm hoping that volunteers is taking care of this.
Yeah. Laiba, are you there?
Yes, sir.
So Laiba, please please provide the sharing right. Make the presenter.
Yes, sir. Yes, sir. Just 1 second. I was doing it. Yeah. Yes, Kevin, I think you can go ahead and share your screen.
Yeah, just a second. Please let me know when you see my screen.
We can.
Yeah. Okay. Yeah. Good morning, everybody. I'm Kevin Rodrigues from KLE Technological University, and I'll be doing the presentation on the topic Integrated Crowdsourcing Framework using Deep Learning, Digitalization of Indian Heritage Infrastructure. So this will be the content that I'll be going through during this presentation. So I'll be going through the introduction, motivation, and the objectives and problem definition that we have defined, and proposed methodology, results, conclusions, and the references. So I would like to brief my introduction in 2 to 3 points. The first point is what we have done. So we propose our work on building a fully fleshed web application using emerging technologies to aid the preservation of cultural heritage site and its related data, and to build a deep neural network which classifies heritage sites with the crowdsourced data. Yeah. And why did we do? So India is known for its rich heritage and its culture. The necessity for digitalizing and storing the information of the heritage of our country is challenging due to sheer scale of cultural data collection and reliability of sources. Indian Digital Heritage Space. Uh, this is a unique initiative by the Department of Science and Technology supporting collaborative projects between researchers in the area of technology and humanities. And some of the participating institutions I have mentioned in the slide, you can see that it is from IIT Delhi, IIT Bombay, and various such colleges. And one of them is KLE Technological University, and I am a student at that university. Uh, we all know the fact that we live in an information age, and we are overwhelmed with data, and making the ability to store, process, analyze, interpret, consume, and act upon that data is a primary concern. Developing a very intelligent neural network, a deep neural network that works well for the given input image, needs a very strong data set. And crowdsourcing is one such platform where we can harness this strong this ability. Crowdsourcing works on the principle that more heads are better than one. And we also achieve the superior quality of the images, the content, with the involvement of large crowds for ideas, skills, and participation. So what is the motivation? Why did we come up with this idea was, we know that in this information age, about 90% of the data in the world every day is unstructured data, and its volume is growing 55 to 60% each year. And it is difficult to analyze and not easily searchable. But if we harness it correctly, it could become a valuable asset for an organization. And crowdsourcing platforms are rapidly replacing these traditional modes, these traditional methods. Crowdsourcing is changing the landscape for the quantity, quality, and type of the labeled data set available for training data-driven machine learning systems. And we have concised all these motivation and all these aspects into two objectives for our work. The first one is to develop a web interface for managing crowdsourced images of Indian archaeological heritage sites. And we also want to give functionality, and also want to develop a functionality which can categorize images for the known classes, and trains the existing model for new images with new labeled classes. And we have defined our work into a problem definition that goes like this: to develop an automatic interactive web interface for crowdsourced images of Indian digital heritage sites, which automates the process collecting the data, pre-processing the data, and a custom deep learning system using transfer learning. And we have designed a conceptual design for this project. Here you can see that there are three major components: the builder, the automator, and the kernel. So the builder is where the human in the loop, where the humans get an opportunity to use this functionality, or play an important role in this conceptual design. So human in the loop are this method is optimized for workflow of data quality control, and it is the interface where human interacts. And we have the automator and the kernel, which triggers the machine learning workflows automatically. And we can see in the training architecture, we have a place where we store the data and validate the models. So this was the conceptual design. And then coming to the users, coming to the crowd, we have categorized the users into three categories. That first one is contributors, validators, and analysts. And each category has some specific functionality, specific privileges to work in this framework. So the contributors role, we can see that whenever a contributor logs in into this framework, he can upload an image and get an inference out of it. So he can upload an image of an Indian heritage site. If he doesn't to know what its description, its information, and the framework actually, the model will predict the class, the heritage site, and give its relevant information. And the contributor, as the name suggests, he can also contribute the data. So the data is nothing but images, the captured images of Indian archaeological sites, and he can contribute this data, and he can tag the image with a known class if it is available. Now comes the validator's role. Who are the validators? Validators also have the privileges of the contributor, but they also have the major privilege of discarding the image that is contributed by the contributor. So he can validate the images, whether it is true, false, or if it is irrelevant. If the image is irrelevant, he can discard the images. And validator has another privilege of uploading a new class. He can add a new heritage site and also upload classes to it. And then comes the analyst. The analyst is the machine learning practitioner, we can say, where he checks the work, he can retrain the model using transfer learning techniques, using different machine learning, deep learning techniques. So the next one is description of target users and their workflow. So we can see the human interaction and the data flow, where you can see they are in 3 levels, and the framework is built with academic hierarchy and student collaboration in mind and reference. So why we are restricting, as it is the initial phase, we are restricting this web framework to academic hierarchy, that students can upload the images, and other levels of the academic hierarchy can be the validator who validate the images. So the data will be flowing from the top, like the crowd workers can add a sample, can and annotate it, and then the data set is generated automatically, and this whole process continues, and the machine learning practitioner, he can approve this data set, and then he can practice his machine learning techniques on it. So so where do this where is this data being stored? So in the server, we can see we have as we have 3 types of users, 3 categories of users, we have stored 3 levels, 3 stages of information, the image filtering. So in the first level, what we store is the contributor's images. Whatever images the contributor uploads, these get over here. This can contain these can contain the discarded images or the irrelevant images, everything that a contributor can upload. And then the validator will validate each of these images, just like how we see in a gallery. He can just tag it, whether it is true, whether it is irrelevant, or he can discard it, and the discarded images fall in the bin, like the other images folder. And then the validator can approve these images, and the approved images will come to the next level of the data hierarchy, data storage hierarchy. And here the images are like, we can see that images are kind of bit filtered due to with the help of human in the loop. And these data, which are in the second level, are analyzed by the analyst. So the analyst can approve the new classes. So the new classes can be approved, and then once he confirms all these things, he can train the model with the new classes as well. So the data looks something like this. So these are the images captured captured by the contributors, the validators, and we can see that the manually collected data, initially we have built this machine learning deep learning model with 70 classes, which has 155,975 images, which is of 352 GB, and using this crowdsourcing platform, we have collected 37 new classes of 8 GB, and in total right now we have 107 classes. And we have also pre-processed the data, automatic pre-processor, using and the steps are removal of duplicate image, removal of non-region of interest, and scaling the image. So these are the pre-processing steps that we have applied. Now you can see the these are the results. So let's come to the results now. So here we can see the snapshots of the interface that we have built. So the first page, what you can see is where a contributor or any user who logs in can upload an image and then can the prediction, and immediately it predicts which temple or which monument it is. So this is the inference functionality, and the model what we have used here is MobileNet V2 architecture. Mobile V2 architecture is optimized for mobile devices. And why we have chosen MobileNet V2 architecture is because it is trained on ImageNet dataset, which has 1,000 classes, which is very powerful, and it is optimized for edge devices. And also in the future scope, we are thinking of moving this model to the edge devices in the mobile phones, where the user can automatically do the inf. Now is 98.75. Not. So next functionality is tag functionality. So what functionality? Now the contributor wants to content. So what it does is he can upload an image and select from the drop down whichever, or he can search for what it is, which temple it is, and he can annotate the image. Next functionality is the validator's role. So what the validator can do is, if there is a new site, he can create a new class, he can create a new heritage site, and this gets stored independently. This is something, this snapshot is something what the interface looks like when a user uploads a new class, or he wants to create a new class. So he can upload an image, a cover image for that. He can upload the name of that monument, and he can also give a description of that class. And the analyst role. Analyst role is something like he is the machine learning practitioners. He can schedule the jobs, he can schedule the periodic training, retraining of the model, and also analyze the data flow. So this snapshot is a little bit old, like in the sense in the initial stages of the project, but now we see that analyst can change the hyperparameters. He can fine tune the parameters, and also for manual training of the image, he can trigger it, or he can set periodic time using cron job, and all these techniques that are available, the emerging technologies. And this is another work where we have ported this model into a mobile device, and the mobile device is now able to classify,
Kevin,
is now able to, yeah, hello.
Kevin, I think slides are not moving. Maybe this is the analyst role that we can see on the screen. Yeah, mobile application.
So this is the mobile application. So here we have given the, we have ported this MobileNet V2 model into a mobile phone, and then we are able to get the information about that template. So this looks very rudimentary because it is in the initial phase, and our juniors are also working on this. So I'm a student at KLE Technological University. Yeah. So the conclusion would be the framework gives an automated platform for new opportunities to develop and integrate various machine learning applications. Future developments would be deploying this framework publicly. And we can publicly deploy this on the server, and also we can give it to the random crowd. Because as of now, it is restricted only to the students and the academic hierarchy. And the future developments would be, the directions would be in quantization techniques to optimize the model so that applications can be ported on edge devices, and the IDS dataset will also be enhanced, and that can be used for 3D reconstruction of heritage sites to create a walkthrough. And hence this work will also cater to meet further objectives of the IDH project. And for more information about IDH and its initiative, you can go to this website and find more. These would be the references. And so I would like to conclude my presentation, and I'm open for question and answers. Yeah.
Thanks, Kevin. So any questions from the audience? Okay, maybe we can move on to the next presentation. So can I request volunteer to allow the speaker?
Yes, sir. I have enabled his option.
Thank you. Thank you, Midas, for enabling it. Let me share my screen. So, hello everyone. This is Suryansh Tibrewal. I am here with my co-authors Rishabh Gupta and Vaibhav Mathur on this call. Today we are going to talk about realistic polar influence propagation model for location-based social networks. Is my screen visible? Yeah, okay. So to start with, what is exactly a location-based social network? So location-based social network, as it is defined academically, is influence of online and offline network topologies to connect people, and then we are going to study how they're going to influence each other. So to give an example of a real-world location-based social network, it could be as simple as few of me going out with some of my friends to an event, which is on a physical location, the pre-COVID world, of course, and then coming on Facebook and talking about it with a friend who could be living in a different country, let's say checking in about that event. So there are few ways of influence to propagate in a location-based social network. It could be word of mouth, which is me just telling it to my friend. That could be me meeting them on a coffee, or it could be me posting about it online and they end up reading it. The one assumption that is taken in this network is that we have users' location information available with us. Now, in the past few years, we have seen how online and offline world has merged. US election was one of them, Indian election, and content being propagated on WhatsApp is another example of them. So there have been incidents where elections have been targeted with people being influenced by analyzing their network and analyzing their interest and changing their opinions by targeting them, right? And the mix of offline and online location information has been used to do this influence before. So what we are going to do from a research perspective in this, what we have done in our paper is, currently the state-of-the-art research in this field is that mostly it talks only about positive influence, how I'm inclined about a particular topic and I only do influence on those topics. And generally the influence, the models that have been used, and in the base paper also we used to start our research, the models talk about having a Boolean influence. So either you get influence or you don't get influenced. And your interests need to be exactly the same to get influence. But we believe that this this is probabilistic, and this is like more like a gray area where our interests could have a partial overlap, and that could also lead to an influence. Adding to that, we have also something that we have done different in our research is we have used as an initial activation, we use offline and online events both to see how influence can be propagated. So to give an example around interest matching, so we have tried to use two different type of coefficients to see if the interests have a match. So Jaccard coefficient works only when there is a literal match. So if, let's say, I like scuba diving, the other person likes scuba diving, then we consider that we are both similar to each other and can actually propagate and influence. So to take a political example, let's say if I am a particular leader's, if my interest vector has a liking for a particular leader, and another person's influence vector has a liking for a particular political party, but that political party belongs to that leader itself. So in the Jaccard coefficient, there won't be a literal match and influence wouldn't propagate. What we have built on is introducing a soft cosine coefficient, which takes this factor into account. Sorry, my bad. So how did we calculate this interest matching coefficient? So we have made use of word2vec model. So word2vec model is pre-calculated. We have used a news 300 data set from Google, which reads over all the Google news in the world and creates word2vec vectors. What is a word2vec vector? It is a vectorial representation of any entity. This allows us to do mathematical calculations on different entities and figure out if they are close to each other. So we have reused a data set of these vectors and then applied it on our use case. So for our use case, the way it works is we have an interest set. It goes through a word2vec calculation. So taking the same example, let's say if there is an interest set vector of that particular politician. So I'll have my own interest set vector where I'll have maybe 10 different interests, and the other person will have a similar interest vector which will have maybe different 10 interests. Now we will do a dot product on it, and we use weights from word2vec to get the similarity matrix. Now this goes through a soft cosine calculation which allows us to find a net value of this interest match coefficient. Before we move into the model, a couple of things I would like to highlight here, that what we are trying to achieve here is introduce polarity in the influence. So in this word2vec, my interest set could have a negative value of that interest. And the second thing we are trying to introduce is this soft cosine allows us to, even if there was a completely different overlap, we still would be able to find some sort of similarity here, which works more like real world. Vaibhav, do you want to continue from here?
So now I'll start with the polar influence model. So basically, so the essential idea behind this is, in the original research, there was no negative influence. But as we know, like, negative influence is a very popular thing. For instance, if any event is advertised, there are a lot of people who would post in support of the event, and there were a lot of people who would post against the event. So what we do is we describe interest set of a user into two categories. One is pro stance and the other is anti stance. So anti stance just implies that in general, your outlook towards a particular interest is negative in nature. Suryansh, next slide. Next. Yeah, next. All right. So now I'll tell you how the propagation model actually works. So our propagation model is divided into two primary states. First is the initial propagation, followed by additional propagation. Now, in the initial propagation stage, it sort of represents when an event is initially takes place. For instance, in the real world, it could be a product launch, or say or a news or a newscast, and in the online world it could be an advertisement campaign. So the idea behind an initial propagation is that there is an audience which is exposed to that particular event for a certain duration, and post this event is when the audience starts interacting with other people and passing on the influence. So initial propagation, the two primary factors that determine whether a user will be influenced are their interest matching, like how aligned is the user with what the event is, and secondly, for how long have they been exposed. Now, this exposure could mean two different things. In the online world, the exposure would be how many times the user logs in on their social media account. So it's so it's a reasonable assumption to believe that when a user does log in to his social media account, uh, the likelihood of him coming across a particular post would increase. Therefore, the exposure would increase. Similarly, in the offline scenario, exposure would imply for how long the user resides in a particular radius, which could be called the influence radius of the event. Now, post the initial propagation, we start with the additional propagation, which permeates through the online world as well as the physical world. In the online world, it's mostly basically through someone sharing a post and all their friends who are connected to them on social media seeing the post and getting influence. And in the physical world, it's more about people talking to each other. Again, the factor which primarily comes in is how in the influence region of some already influenced user. Next slide.
Just
Yeah. So now these are basically the parameters that we consider during influence propagation. So the first is interest matching, which, like we discussed earlier, is basically how well you're aligned to the interest, to the interest set of that of the event. Second is exposure, which again we've discussed earlier. Then the third is description count. Now, description count is basically the number of posts you see. So what we accommodate for in our propagation model is how many times a user actually posts that. So we make a probabilistic model, which gives a probability of the number of times the user posts about a particular event, which is proportional to his interest matching coefficient. And the third is existence of friendship, and this is sort of based on the agenda that someone who's a friend of yours on Facebook is more likely to influence you on any other on a particular event. Next slide. So so this is the basic how the propagation model goes. We just start with pre-processing of the data, where we build our data structures and the list and the graphs for the LSBN and all the queues which determine how many times the posts and all have been shared, followed by event activation, which acts as which basically leads to initial propagation, and finally the additional propagation. Now, a few important things for us to note are, in our initial propagation, a user, both his negative and positive interest, increase his chances of being influenced. So the polarity is just assigned after the person is influenced. So this sort of represents a scenario wherein if I come across a news, even if I'm negatively inclined towards something, I'm more likely to post it. I mean, more So I negative influence, but probability of being influenced would be higher. So in the initial propagation, we don't have a competition between negative and positive influences. But after that, in the additional propagation, when the propagation happens through our peers, that's when the competition between negative and positive influences kick in, because some users might be trying to influence you positively, whereas the negative group might be competing against that to influence you otherwise. So the real competition kicks in during the additional propagation stage. Now, if we move on to our experimental results, we see some. So this is basically the comparison between these are basically graphs which show a similar trend from the previous model, which sort of explain that which sort of reassure us that the model is following this same topology as the existing model. The really interesting graph which we would like to discuss is the last one. Yeah, this one. So over here, if we were to note, the purple line denotes the influence users from our model, the total influence users from our model. If we notice, the initial point of this purple line is much higher than the orange and the blue line, which represent the positive and negatively influenced users. And this is reassured by the fact that in our initial propagation, there is no competition between the positive and the negative influences. So that's why we tend to see a higher start at this point. And as you can see, as the propagation goes forth, the influence users start to decrease, and that is because of the competition that kicks in. And we gradually see that the purple line, which is the total influence users, falls behind the propagation when only positive or negative influence were switched on. So this is how our model, this is how the experimentation results align with our hypothesis. Suryansh, would you like to?
Yeah. So to summarize our results, we were able to conclude that polarity does make a difference in the influence, especially in the competitive nature of influencing each other. The another thing is polarity is overall just a vectorial direction to the influence. So if something can be influenced, it can be influenced in positive and negative direction both. Our interest matching coefficient research actually helped us align our observations to more real world patterns, because the world doesn't work in Boolean way. Right now, from our current conclusions, especially with COVID coming in, the way was something interesting that we want to observe in future is the impact of COVID, because from the time this research was conducted and the current time, the network topologies have changed considerably, with more people spending more time online. Offline influence will have lesser impact in events, and online influence will start to play a more critical role. And we believe that could lead to much more interesting results. And another thing that which can be a possible improvement on this paper is accommodating for bias in propagation. So that's overall what we did in our research. Any questions?
Thanks, Suryansh and Vaibhav. So we do have good time for a couple of questions. Okay, maybe one question. Yeah. Are there any proactive steps based on the observation?
Sorry, there is disturbance. Can you repeat your question?
Yes, it is there on the side as well. So let me just are there any proactive steps that you can make based on?
I'm sorry, I couldn't catch you properly. Could you repeat the question?
Yeah. So, are there any concrete actionable steps that you can take based on your observation?
Yeah, we could. You mean like where the entire model could be used?
Could be used and could be the next step if from the model gives some output, but are there any actionable outputs out of that?
Yeah. So the model primarily provides us a simulation, simulation of the real world. So a very major step could be, for instance, targeted campaigns. It could provide you positions which would be ideal positions for starting a targeted audience campaign in the online as well as the offline world. So it it encompasses a minimum cost versus maximum output scenario. So in fact, we have not added to this research work, but we also there was an additional part to the research that we had carried out uh, where we had simulated clusters which denote Facebook or like any other groups in the social media, and so we would we would run simulations for all such groups to get the best to get the best target group for with a cost to like benefit analysis. So the benefit would be how many n number of users are finally influenced, and the cost is as to how many people are in the group, because that adds to the cost. So in that way, we can figure out the most efficient groups in the online world, and the best locations for ad campaigns in the offline in the physical world.
Okay, thank you. So any other questions? If not, move on to the next presentation.
Hello, everyone. Am I audible?
Yes.
Let me just share my screen. Can you see my screen now?
Yes.
Yeah. So, this is Saurabh. I'll be presenting a paper on hashtags are not judgmental, the untold story of Lok Sabha elections. I work with Dr. Arun Balaji and Dr. Vandana Kumar Guru, and I'm a PhD student at IIIT. Yeah. So, Twitter is actually being used to break news for a very long time. Let me just so as we have seen that during Mumbai attacks and during scraping of Article 370, a lot of people are actually consuming their news from Twitter. And even today, me and you, a lot of us might be consuming news from Twitter only. We go to media channels after we see something from Twitter. So it is a platform which is being used to break news for a very long time now. Just a minute. There have been previous works that study elections based on hashtags and other countries' politics. So, for example, the hashtag CDN Poly is a very popular hashtag for Canadian politics, and a lot of studies have been done on that. Similarly, for Iran elections, and we all know that a lot of work has been done and going on to understand US elections, especially the one happened in 2016, because there was a lot of a lot of polarization and malicious activity around that. So there are some studies that use only hashtags to perform empirical analysis of tweets to understand what all can be done. So the idea is to use as minimum information as we can to uncover a lot of things. Just a minute. Yeah. So we wanted to study several aspects of Indian elections, and to do it, we obviously need a big data set. So that is why we did this study. So as you can see, even the official platforms like Election Commission of India, they use Twitter to break news and events. They have created a poll in this particular tweet. So there are a lot of tweets that were going around about elections, and we wanted to collect all this data so that we can actually study a lot of phenomena and behaviors around elections. So summary of contributions is a 1 million tweet dataset to study elections in India. And we did some analytics using just hashtags, which involves using semantic similarities to uncover some things, and using trends and topic modeling to uncover a lot of data. So to the best of our knowledge, this is the first and largest dataset to study Indian elections. So Indian politics has two bicameral kind of structure where we have an upper house and a lower house, and the lower house is mostly responsible for making any laws or anything. And this election was happening for lower house of the parliament. So it was really crucial to collect this data to actually study what people think of the politics and all. So that is why we focused on Lok Sabha elections. So the lower house is actually called Lok Sabha, and the elections happen in 7 phases. In each phase, there are elections in some states, and there are no voting days in other. So these are the actual dates, as you can see, for each phase. So during our data collection strategy, we actually divided data collection into 7 phases, and based on that, there are 7 parts of our data. So for data collection, we went with Twitter API, through which we collected these tweets based on keywords. So for during these phases, we manually, check which is a trending hashtag. So for example, hashtag elections 2019 is trending. So we add it to the streaming API, and we collected data in this way. So these keywords are selected according to what keywords people are actually using to, generate tweets. So a summary of statistics of these are, like, we had around 8.22 million original tweets. The total number of tweets, total hashtags in tweets was 24 million, and the rest of the tweets were quoted retweets or just simple retweets. The maximum number of hashtags in a tweet was 7, the minimum is 1, and average number of hashtags per tweet was 3. So to verify that our data collection strategy was right, we prepared these word clouds. We can see that there were hashtags like voting round 1, voting round 2, phase 3, voting round 4, phase 5 in their corresponding bucket. So this shows that the phase 3 collection is actually correct because it has phase 3 hashtag lot of number of times. The frequency is. So as you can see, the election happens on a single day, and then there are no voting days. So we divided the duration in this way, assuming that if people vote on April 11, they will talk. The more talk will be about those states and those votes during these dates. And the election counting was on May 23, so we divided the last phase from May 19 to May 22. And as you can see here, you can see exit poll in the phase 7 election. Yeah, so on the basis of counts, we observed that hashtags like Is Baar Namo Fir Se and other BJP supportive hashtags were constantly trending throughout the phases. On the other hand, we observed mixed sentiments, hashtags trending for other political parties. So this is a general trend that we can see in this word cloud. Now, we performed content-based analysis on the tweets to see that people preferred to use less hashtags per tweets. So as you can see, distribution of number of hashtags. So the max is 7, the min is 1, and the number of tweets with only one hashtag is like quite high, and with 7 is quite low. So this obviously follows a power law distribution. And similarly, figure 2 shows that there were more unique hashtags that were being used. So for example, if I'm a Twitter user, I will just create, a new hashtag and post my tweet instead of just, copy pasting some other hashtag. So this is a phenomena which is, so that is why we have lower number of hashtags tweeted a lot of number of times and unique hashtags. Yeah, so for finding events, we cross-reference the top trending hashtags with the dataset to get a list of tweets. From these tweets, we actually took out random samples to map with notable events that happened in the course of Lok Sabha elections. So this is just to show the peaks in our data, like if a hashtag is trending, why it is trending. Just to find out these things, we just did it randomly. So there are some of the notable events. For example, hashtag Modi biopic was used during the first phase, which mapped to the release of the controversial movie on Narendra Modi. Another example could be the use of entire cloud cover, this example, which mapped to the controversial interview on the topic of surgical strike. So during these events, these hashtags were really prominent, and this is what was captured in the data. To extract topics from hashtags, we treated hashtags as words and group of hashtags as sentences. So for each tweet, for example, if a tweet has 4 hashtags, it's a sentence with 4 words, and performed LDA to find the latent topics. The table shows some of the topics with their respective hashtags. We just picked up the 6 of them. These topics are assigned subjectively, and these are the hashtags associated to a single cluster. We have used coherence score to find optimal number of topics. So we tested it with K as a multiple of 5, and we ranged the experiment from 5 to 100, and we found that 20 is the optimal number of topics for this case. So we also want to see the real electoral battles compared to the social media battles in a simple manner, since we are using just hashtags and not any additional information. For finding the top trending battles across the elections, we search for hashtags containing VS or versus. So as you can see, this Smriti Irani versus Rahul Gandhi, Gautam Gambhir versus Atishi Marlena, Sadhvi Pragya versus Digvijay. So we just stick to these 3, and we proposed this influence, a metric called influence, which was calculated by comparing the amounts of positive sentiments and negative sentiment hashtags towards these candidates. To find out the negative and positive, we actually did a manual annotation process for this thing, and based on the count, we just summed all the positive ones and subtracted all the negative ones to come up with these scores. We also performed a skip-gram analysis to find semantically similar hashtags to 4 hashtags. So this hashtag Modi, hashtag Raga, hashtag BJP, and hashtag Congress, these are the 2 most prominent candidates. These are the two most prominent candidates, and these are the 2 most prominent parties. So there are 543 seats in Lok Sabha elections for which candidates contest for, and BJP and Congress had 435, 420 candidates fighting for it. So these are by numbers the biggest parties in India. So we just picked up their hashtags. So we got to see some interesting results here. Hashtags like hashtag Bhakt and hashtag Chaukidar are found to be semantically similar to hashtag Modi, while hashtags like Pappu are found to be semantically similar to Rahul Gandhi. So there are actually blogs and news which call Rahul Gandhi as such, and we have cited all these things. So these are just similar sentiments which are going around about these people, and we are able to see decent results. Yeah. So this dataset was actually an effort towards studying Indian elections. There are a lot of projects and a lot of studies that are going on in this data set. So, for example, there are some privacy concerns, which is called a voter privacy leak. So, a voter privacy leak is something when you actually end up revealing your vote, while it should have been kept secret. So we did this study and it was published in SOC.info. Similarly, other people from our lab are studying bots using this data set. There are studies on shift in online political discourse using this data set, and there are a lot of other studies that are currently being done. So there are account suspensions, social contagions, characterization of politically active users, and studying operations by IT cells. So there's a long way and a lot to do with this data set. So this data set gives us a starting point to study Indian elections and see patterns and actually compare them with Western economies and see how they differ. I would like to conclude here. My webpage is, my name is Saurabh, and I'm on Twitter as Directory Saurabh. If you have any questions, you can ask.
Thanks, Saurabh. So we have good amount of time for questions. All right, so it's like we don't have any questions for now. So I think that was all. So maybe we could end the session here.
Okay.
Yeah. Thank you, everyone.
Thanks, Subramaniam. Thanks, Laiba. Thanks, everyone.